Good morning, students. Am I audible? We have been working on Unit 1 and Unit 2 of HWRE. Unit 1 was Introduction to Hydrology, and Unit 2 is about the runoff calculations. So, today we are going to see some numerical problems on these two units, as we have already covered like almost every theoretical part of the first two units. I hope you have bring your notebook, pen, and calculator with you, so you can work with me and try to solve the problems. If you are in difficulty during the problem solution, please let me know. Okay, if I'm not audible or if there is disturbance, please let me know. Okay. Okay, so let's see. The first problem is, in a given year, a catchment with an area of 2,500 kilometers square received 1.3 meter of precipitation. So you have to pay attention to the units. Okay, we are talking about the area which is in kilometer square, and we are talking about the precipitation which is in meter. The average rate of flow measured in a river drainage, the catchment was 30 meter cube per second, is cubic meter per second. Now the question they ask is to how much total river runoff occurred in the year, and that we need to find out in the meter cube or cubic meter. The second question is, what is the runoff coefficient? And the third, how much water is lost due to the combined effects of evaporation, transpiration, and infiltration, and that we have to express in meter. So let's see how can we solve. So for the first, the total runoff volume can be found or can be calculated using the formula number of seconds in a year times average flow rate. So number of seconds. So number of seconds, how we can get it? So 365 days times 24 hours in a day times 30 minutes in an hour times 60 seconds in a minute. Okay, so basically you are going to multiply 365 times 24 times 60 times 60. So you will get 536,000 seconds. Okay, so those are the calculation we can get for the number of seconds in a year. Now average flow rate they have already given in the problem, which is 30 meter cube per second. So that's why it's 30. You multiply that and you will get the total runoff volume, which is in 9.46 times 10 to the power 8 cubic meter. Second, runoff coefficient. So we have already figured out, or we already calculated the runoff volume. So runoff volume divided by precipitation volume will give you runoff coefficient. Now, how we can calculate the precipitation volume? So precipitation volume is nothing but the total area times the precipitation. Okay, so it's area times the depth will give you volume. So 2,500 kilometers square. So we have to convert that into the meter square. So 1 kilometer is equals to 1,000. Sorry, 1 kilometer equal to 1,000 meter. So 1 square kilometer equals to 10 to the power 6 meter square. Okay, so that's why they have multiplied 10 to the power 6. So 1.3 times 2,500 times 10 to the power 6. You get the answer in 0.29. So that is the runoff coefficient. If you want to express this runoff coefficient in percentage, so you can say it's 29%. Okay. Third, they have asked about the how much water is lost. Okay, so we have to find out the water loss. Okay, for evaporation, transpiration, and infiltration. So we are going to write the water balance equation, which can be written as ET, okay, evapotranspiration plus F equals to P minus R plus delta S. So P is precipitation. So we have already figured out the precipitation, which is 1.3 times 2500 times 10 to the power 6. So it is going to be 3.25 times 10 to the power 9 meter cube. Then R is runoff. So we have already figured out runoff, which is 9.4608 times 10 to the power 8 meter cube. Now, the S or delta S is storage. Okay, and delta is basically change in storage. So there is no change in storage, so that's why it's going to be 0. Now ET plus F. Okay, so ET plus F, that is the what you can call as the losses. Okay, so evapotranspiration and infiltration. Okay, so those are we have. So sometimes you call it as F, or sometimes you call it as I. Okay, for the infiltration. So ET is evapotranspiration. So you put all these values in this equation, and you will get the total loss in meter cube. Okay, now that is the volume in meter cube, but in the problem they have asked you to express your answer in meter. That means you have to divide volume by area, so you will get the depth or height. So that's why they have divided this by 2500 times 10 to the power 6. You will get answer in meter. Okay, so up to this point, do you have any question, any problem, any doubt? If don't, we can move on to next problem. Okay, so let's move on to next problem. Water at a constant rate of 370 cubic was observed to be entering into turbulent reservoir in a certain region. So they haven't mentioned any season. Okay, they say certain season, so it might be a monsoon season or summer or winter, we don't know. And 370 cubic, so cubic is nothing but meter cube per second. Okay, so meter cube per second or cubic meter per second, we call it as a cubic. So if outflow from the reservoir, including infiltration and evaporation losses, is 280 cubic, find out the change in storage of reservoir for 10 days. Also convert your answer into hectare meter. So they are asking to convert your answer into hectare meter. Sometimes they also can ask you to convert your answer into hectare inch. Okay, because that is the most popular unit used in India. Okay, hectare inch. Now we know I, which is 370 cubic. So I is here input. O, which is output. So we know output is 280 cubic. So inflow and outflow. In I for inflow, O for outflow, or you can say input and output. So something like that. Inflow and outflow. Now delta T, so time difference or duration or period, that is 10 days. So again you have to convert the 10 days into second. So 10 days times 24 hours times 3600 seconds, and you will get time in second. Now delta S, again delta S is storage, so delta S is change in storage. So according to our water balance equation, I inflow minus O outflow should be equal to delta S or delta T. So we can get 370 minus 280 equals to 90 cubic. So delta S or delta T is 90 cubic. Now we already know delta T, which is 864,000 seconds. So we can multiply 90 cubic by delta T to get the delta S. So now we can get delta S, which is 7,776,000 meter cube. Now that is what we got in meter cube, okay, or cubic meter. Now in the problem they ask you to get your answer into hectare meter. So hectare is a unit of area and meter is the unit we can consider as a depth. So hectare, 1 hectare equals to 10 to the power 4 meter square. Okay, 1 hectare equals to 10 to the power 4 square meter. Okay, so to get our answer in hectare meter, we are going to divide our meter cube by 10,000 to get the answer in hectare meter. Okay, that's how you can get the answer. Now if anyone have any problem, any doubt up to this point, please let me know. Otherwise we can move on to next problem. Okay, so we can move on to next problem. Problem number 3. In a given year, a catchment with an area of 1,750 km square received 1,250 mm of precipitation. The average rate of flow measured in a river draining the catchment was 25 meter cube per second. So question 1 is calculate how much total river runoff occurred in a year, okay, in meter cube. Second, calculate the runoff coefficient and what is the percentage runoff. So again you have to note down the area of catchment, which is in kilometer square, and you have to convert that into meter square. So 1,750 kilometer square becomes 1,750 times 10 to the power 6 meter square. Now flow rate in the river, which is already given, 25 meter cube per second, or also sometimes they call it as a cubic. Precipitation received equal to 1250 mm, which is basically 1.25 meter. Okay, this is the information provided in the problem. Now the total annual precipitation is 1.25, so precipitation received times the area. So catchment area is 1,750 times 10.6. So that will give you total annual precipitation, which is 2,187.5 times 10.6 meter cube. So this is the answer in cubic meter. Now flow rate during the year. So flow rate is basically your volume divided by time. So we know the volume, which is we all just calculated, and the time basically 365 days. So it's a yearly. So 365 days times 24 hours times 60 minutes times 60 seconds. So if you do the calculation, you get answer 69.36 meter cube per second. Now the next is runoff coefficient. So runoff coefficient equals to annual flow in river divided by total precipitation occurred. So annual flow, which is already given in the problem, 25 meter cube per second, divided by total precipitation occurred, which is we just figured out 69.36 meter cube per second. So runoff coefficient is 0.36. And if you want to know this in percentage, so you can say 36%. So just multiply by 100 and you get the percentage. So at this point, do you have any queries, any problem, any doubt? Otherwise, we can continue with the another problem. Okay, no. Then